Hi everybody, welcome back to Conceptual Physics. We're rolling right along. We finished chapter 1 and we're moving on into chapter 2 about linear motion. Our objectives for this chapter are to explain the idea that motion is relative, define speed and give examples of units for speed, distinguish between instantaneous speed and average speed, distinguish between speed and velocity, and describe how to tell whether a velocity is changing. So we have a lot to cover here. So the introduction. First of all, what we need to know is we're going to be talking a lot about rates. A rate is a quantity divided by a time. 3 rates of motion that we're going to talk about in this chapter are number 1, speed, number 2, velocity, and number 3, acceleration. So let's get started. So section 2.1 in the book talks about the fact that motion is relative. When we describe the speed of something, we are relating its speed to the speed of something else. An example is when I'm standing still, I am moving 0 meters per second compared to the floor, but I'm moving 30,000 meters per second compared to the sun. So it depends on what you're comparing your motion to. Section 2.2 is about speed. Speed is a measure of how fast something is moving or the distance covered per unit of time. Some units for speed that you should be familiar with, some of these are meters per second. This is the SI unit. Kilometers per hour, which you would use if you were in Canada. Miles per hour, which we use here in the United States, and if you're going over really long distances, light years per century. Now, when we talk about speed, we talk about a couple of different types of speed. The first is instantaneous speed. That's the speed this instant. This is measured on the speedometer of a car. We might also talk about our average speed. This is the speed that we are going across a trip, when we take a road trip perhaps. Because you do not travel the same speed the whole time. Now we're going to be using an equation for speed, especially in our labs that we're going to be doing. We're going to do a couple of labs with this. Speed and velocity have the same equation. So it says velocity. We're going to use the V for velocity when we're solving for speed. So velocity equals change in distance divided by change in time. I have it here in word form and down here in symbol form. The little triangle means change. It's the Greek letter delta. Now, a word problem you might see with this is if you ride a bike 5 meters in 1 second, what is your speed? So the first thing we always start with is our equation. V equals delta D over delta T. Always write that down. So as I go through these slides, you're going to see the word problem at the top each time. You don't have to rewrite that. Just write the part in gray in your notes. I'm just keeping the word problem up there so that we can see the numbers and insert them into our equations. So when we insert our numbers in, I put 5 meters on the top because that's my change in distance. I put 1 second on the bottom because that's my change in time. And when I do the division, 5 divided by 1 is 5 meters per second. Now here, that's a division sign. My meters were over my seconds, so I keep that in my label for my units. Let's try another problem. If you ride a bike 100 meters in 20 seconds, what is your speed? So again, we start with our equation. Always write down the equation. We substitute in our numbers. I put 100 meters on the top because that's my change in distance, 20 seconds on the bottom because that's my change in time. When I do the division, 100 divided by 20, I get 5 meters per second, the same as the other problem, the last problem. Okay, let's talk about velocity now. Velocity is speed with direction. That's why we can use the same equation. So, for example, I might express a velocity as 20 meters per second west. The 20 meters per second is the speed, the west is the direction. Now, whenever we have a number with a direction or a magnitude plus a direction, we call that a vector. We're going to be talking about vectors a lot. So force is also a vector quantity. Speed, or I should say velocity, is a vector quantity. Constant velocity requires both constant speed and constant direction. So if you're going along at a constant speed, but you switch from going north to going east, you've changed your velocity. If you are going east, but you change your speed, you've changed your velocity. Constant speed means the same speed, not moving faster or slower. You can change your direction and still have constant speed. Constant direction means motion in a straight line. And velocity changes if speed or direction change. And that's an or. They don't both have to change, only one or the other, like I talked about before. Now, I have a question for you. What three controls change the velocity of a car? So, to rephrase this a bit, what three things in a car can change its velocity? So, pause your video for a second and think about that. Number one is the gas. It increases speed. Number two, the brake. It decreases speed. And number three, the steering wheel, because it changes your direction. Now let's do a velocity problem. So very similar, this is going to look just like the speed problems, but there's going to be one change in your answer. So if an airplane travels 500 kilometers due north in 1 hour, what is its velocity? So we start with the same equation as speed. V equals delta D over delta T. We plug in our numbers. 500 kilometers on top for the distance, 1 hour on the bottom for the time. We do the division and we have 500 kilometers per hour north. Now, what's the difference between this and our speed answers? It's adding this direction. If you're have a velocity problem, you must label it with a direction. Let's try another one. Okay, this time we have an airplane traveling 250 kilometers due north in half an hour. What is its velocity? Start with the equation. Substitute our numbers, 250 kilometers on the top for the distance, half an hour on the bottom for the time. Now remember, when we're dividing by a fraction, the next step is dividing by a fraction is like multiplying by its reciprocal. So this problem becomes then 250 kilometers times 2, because we flip that fraction over to solve this. So 250 times 2 is 500 kilometers per hour north, the same as the last plane. Okay, different numbers, same speed. Let's try one more problem. If an airplane travels 125 kilometers due north in a quarter of an hour, what is its velocity? Start with the equation. Don't skip the equation. We plug in our distance on the top, 125 kilometers, 1/4 hour, a quarter of an hour on the bottom. Remember, dividing by 1/4 is like multiplying by 4. So here, I've flipped my fraction over. I'm now multiplying by 4. So 125 times 4 is 500 kilometers per hour. Remember, with this label, it's the distance divided by time. And because it's a velocity, we have to have north here. We have to have our direction. Remember, a vector quantity is a magnitude plus a direction, a number plus a direction. So what we covered in this video is we explained that the idea that motion is relative, defined speed and gave examples of units for speed, distinguished between instantaneous speed and average speed, distinguished between speed and velocity, and described how to tell whether a velocity is changing. Now, make sure you have all of your notes filled in. If you don't, go back. And also, remember those 5 questions in your margin for the video. And I'll be back with more about motion in the next video.